Okay, so for the next example, we have y equals 2x plus 3. That's my f of x. And then first thing we do, again, switch your x and y, and then solve for y. So in that case, I move the 3 to the other side and divide everything by 2. I end up with y equals x minus 3 divided by 2. Okay, that's my inverse function. So now let's talk about the domain. Okay, if you look at this, y equals 2x plus 3, this is a linear function. So that means it's always going to be all real numbers for my domain. Okay. On the contrary, also for the same, the range would be the corresponding one, so that means it's also going to be all real numbers. Okay. Next thing, my range. Okay, we don't know that, so in that case, look at this domain. This function here is also a linear function. X minus 3 divided by 2 is also linear. Therefore, it's going to be all real numbers as well, which implies that my range is also all real numbers for my f of x. Okay, so keep that in mind. This is my f inverse. This is my f. Okay. Okay. So we'll talk about the verification in a little bit. So before we do that, we talk about the composition of functions. Okay. F. This is what we had before. F of inverse of f of x. Okay. That's the same thing as f of inverse of f of x. Okay. This is synonymous with each other. It's just different notations. Okay. That's one form. The other form is inverse of f of x, where the inverse is on the outside and this is on the inside, but if it's on the outside, just switch these around. You end up with the same thing. Okay, so how do you grasp this? It's very similar to the idea of f of x and f of 2. Okay, so the x that we have here, and then we have 2 over here. So that means this function, for all values of x and f, you plug in 2. So that means f of 2 is just going to be all values of x equals 2 in the function f. So that means for functions like f of inverse of f, that means for every value of x you see in f, you plug in inverse of f into that function. Okay? And then simplify. Okay, the next thing here is inverse of f. Okay? So for all functions of inverse of f, for all x values of inverse of f, plug in f of x. So the big idea here is whatever is outside, that's your big function. That's on the outside. And then your substituted thing will be the thing that you use in the inside. Okay? So when you verify inverse functions, if f of inverse of f equals f of inverse of f, if they equals x, if both equal x, that means they are indeed inverse of each other. Okay? So the example we did earlier, example number 1, y equals e to the x, that's my f of x. ln of x is my inverse of f. So that means f of inverse of f, my f is e to the x. So whenever I see x, I plug in ln of x. And that's what I have. E and ln of x will cancel each other out. That's my x. Okay? Now the next thing here is inverse of f of x. Okay, then my inverse function here is ln of x. So you see an x here, you plug in e to the x. So you end up with ln of e to the x. And because ln and e are indeed inverse of each other, it's a property we talked about earlier in the semester, in the year, that both equals x. Therefore, it means f and inverse of f are indeed inverse of each other. Okay, so over here, let's go and verify the function for this one. Okay, so my f of inverse of f of x. Okay, what's on my outside? My outside function here is my f, so it's 2 times x minus 3 divided by 2, and then plus 3. So doing the math, the 2 and 2 will cancel. We end up with x minus 3 plus 3, which is equal to x. Okay, that's part 1. We checked. Okay, that's good. Now the next part here is inverse of f on the outside. Okay, so an inverse is it's going to be something minus 3. So it's going to be 2x minus 3, and then 2x plus 3. That's my original function over here, and then minus 3 over here, and then divide everything by 2. Okay, negative 3 plus 3 is 0, so 2x over 2 is equal to x, and yes, they both equal x. Therefore, we come to the conclusion that this and this are indeed inverse of each other, and that's how we verify that. Okay, next example, f of x equals 3x minus 1 over x plus 5. Okay, step number 1, switch your x and y, and then solve for y. Okay, when we're done with that, talk about the domain and range, and then verify. Okay, so this first thing we did, switch my x and y, I get x is equal to 3y minus 1 divided by y plus 5. Next thing here, I'll multiply the y plus 5 to the other side. So you have x times y plus 5, and then equals 3y minus 1. multiply everything in, you have xy plus 5x equals 3y minus 1. And the next thing you're going to do, put all your y's on one side and put on the x on the other side. And for the one with the y side, factor the y out. So that's what we did here. We factored the y out from here, so you end up with y times 3 minus x. And you have y by itself, and divide 3 minus x to the other side. So you end up with y equals 5x plus 3 divided by 3 minus x. That is my inverse function f of x. Okay, so let's talk about the domain and range. Okay, so look at this function here. Okay, the domain here is when all the numbers except the denominator equals 0. So the part where my domain when this function doesn't work is when x equals 5. So in case it's all the numbers excluding x equals 5. Okay, so again, domain of my f is the range of my inverse of f. So in that case, make sure you switch your y, this to y. So it's all the numbers except y equals 5. Okay, next thing, the range. Okay, this range is kind of hard to find because we don't know what it looks like. So we come back over here. So inverse of f, what numbers can you not put in here? It's when the denominator equals 0. So in my case, x equals 3. So in case, it's going to be all the numbers except x equals 3. And then you switch it over here, and you have all the numbers except y is equal to 3. Okay, because range is stuck with y, domain is stuck with x. Don't make the mistake of messing it up. Okay? Next part is the verification. So f of inverse of f in this situation. So in case my f is on the outside, so you're going to use this for all values of x in here. You replace it with 5x plus 1 divided by 3 minus x. Okay, so let's go ahead and do that. So 3 times 5x plus 1 divided by 3 minus x. And then the x we have here, we have, again, 5x plus 1 divided by 3 minus x. Okay, so the next thing you realize is, let's go ahead and simplify this. As you may have already noticed, you have a common denominator, and you have a constant here. So you're using fractions, multiply this and this by 3 minus x, and then put it all together, you end up with 3 times 5x plus 1, and then 1 times the denominator, 3 minus x. Okay, don't forget your minus signs. Okay, and then this one here is just going to be 5x plus 1, and then 5 times 3 minus x. Okay, so multiply everything out, simplify, we end up with 16x over 16, which simplifies as x. Okay, that's what we want. Now, next part, inverse of f of x. So my inverse is going to be outside, so it's going to be following this. So you replace the x in here with 3x minus 1 divided by 5 plus x. Okay, so it's 3x minus 1, x plus 5, 3x minus 1, x plus 5. Again, same procedure. If you see a constant, you have to, if you want to add them, you have to get the same denominator. Okay? Because they both have the same denominator, they can cancel. Okay? You can't cancel without simplifying it first. So the 1 becomes multiplied by x plus 5, the denominator. And then the 3 will multiply by the denominator, x plus 5. So this simplifies as this. You expand everything, you end up with 16x over x, and that equals x. Okay? So make sure you spend some time looking through this process. Make sure you get it, but the big picture is you need the same denominator to do adding and subtracting fractions. Okay? So I'll do one more example after this one, and then if you have questions, let me know. Okay? See you in the next video.